Most of your life, when you talked about angles, you were using degrees, right? And we said that there's 360 degrees in a circle. And you were perfectly happy with that. And then you took your college or high school calculus class, and all of a sudden, you started talking about a different kind of measurement. You started talking about radians. And so I want to talk about that a little bit just to remind you what a radian is and where it comes from. Because we're going to find this unit of subdivision of an angle much more convenient than degrees. Okay? So let's remember that the circumference of a circle is the distance around it, and it's 2 pi r, where r is the radius of the circle. Okay? And then let's say we wanted to find a coordinate system where the distance that we go around, so in this case the circumference, is, so we define what we call the arc length. So if we make this some angle theta, then the arc length is a distance s, and we say that s is equal to theta times r. Okay? So in other words, so there's a bit of ambiguity on whether or not we call radians an actual unit or not. But we notice if we're going to call s a distance, then this is a length, right? S is a distance, so it's a length. R is a radius, that's also a length. So in a way, we can consider radians as actually a unitless unit. And if we do that, we notice that, so in the case of circumference, it's telling us that in a complete circle, there are 2 pi radians, right? Because theta is equal to 2 pi gives us the circumference of a circle. Okay? Similarly, we see that if we say that theta is equal to pi, okay, so then that means that our distance s is equal to pi times r. And so, this is telling us this distance s is, halfway around. That was terrible for me trying to trace a line. I think my 2-year-old can do a better job than that. So we trace this line around, and so s is, is half of the circle, right? And so if we want to convert back and forth between radians and degrees, we notice that this means that that 2 pi radians is equal to 360 degrees. So 1 radian is equal to 180 divided by pi degrees. So so you can see why there's other people that kind of want to argue that you can also call radians, you say that it has to be a unit itself, because when you want to do some kind of unit conversion, you need to make sure you're keeping track of radians and degrees. But I find it more useful, especially in physics applications, if we just consider, if we write something in radians as just a number, because of the way that we want the units to match up on both sides. Okay, and the reason that I'm reminding you of this, and the reason this is useful, is because this allows us to talk about distance as a function of the angle that something's gone around in a circle, and the radius. And that's really what we're going to want to do in this unit, because we're talking about rotation. And as we're going to begin to see, it makes it a lot easier to talk about rotation when we switch to angular variables, as opposed to the linear variables that we've been using so far this semester.